The final unit for Trig, Unit 4, we're going to be covering polar coordinates and the complex numbers. I want to talk about polar coordinates. The best way, I think, to describe polar coordinates is that ultimately what we're doing is we're taking our coordinate plane, right? We have the X, Y coordinate plane that you've always known, right? The four quadrants, 1, 2, 3, 4, etc. But instead of looking at this in terms of two uh, two axes, um, what polar coordinates do is you think about standing at the North Pole, or even like as a drone of the North Pole and looking down. Here's the North Pole. Well, the Earth would be nothing more than a bunch of circles, right? So polar coordinates are coordinates in a 2D space. Then instead of having an X and a Y axis, they have uh, some angle theta, right, and some distance away from that angle. All right, so to jump in, here we go. To discuss polar coordinates, we need to understand that polar coordinates and the coordinate plane are really one and the same. They land on top of each other. Coordinate points could be either in polar or rectangular form. So if you hear me say rectangular, we're talking about just the traditional X, Y. And polar, we're talking about this new set of circles, right? So polar coordinates, uh, polar, really, there's two O's, yeah, coordinate are in the form of r comma theta. So r, just can't see that. R is your radius, right? How far away from the origin are we? And theta, what angle are we facing? And whenever we do, when we go to plot these, I like to think about if I were to stand at the origin, where do I face and how far do I go? And that helps me get there. There's two conversions that we can use. Cosine we know is x over r. That seems fairly familiar. Sine is y over r. Uh, r squared, right? The radius squared is equal to x squared plus y squared. We knew that, this Pythagorean theorem. That's what we're going to have to use to convert from one coordinate system to the other. And theta is tangent inverse of y over x. Now here it says note tangent inverse has a domain between negative pi over 2 and positive pi over 2. So all the tangent angles that we get are going to be the angles that are over here. So if we're dealing in polar coordinates and we need to land in quadrant 3 or 4, we need to make sure we understand what angle we're using, because in our calculator it might not kick back exactly that way. All right. So convert the following to polar coordinates, r comma theta. Give the value of r as an exact value and give the angle in degree form. And really, the only other thing I want to say about the conversions here, uh, when we're going from rectangular to polar, which is what we're about to do, they give us this x squared plus y squared equals r squared. Yeah, that's the Pythagorean theorem. But I also want you to see like visually how we get there. Um, theta equals tangent inverse of y over x. And yes, that is true. We could just plug these values in to get what we need. However, I want to draw visuals why we're getting there and how that happens. But whenever we go from polar to rectangular, when that time comes, it's helpful to see like if I multiply both sides of this by r, right? R times cosine theta is the x value, and r times sine theta is the y value. So this might be a little bit easier to use when that time comes. All right, so let's convert these. Sorry, convert the following polar coordinates, r comma theta. Give the value of r as an exact value and give the angle theta in degree form. I'm probably going to say to the nearest tenth. just to be safe. All right, so we have negative 512. And I look at that, negative 512. That's going to be somewhere up here in the second quadrant, right? And if I draw straight down to the x-axis and the origin, that's the, oh, that's terrible. All right, that's the triangle I'm dealing with. So I know that distance is a 5, that distance is 12, even though the x-coordinate is negative 5, right? 512, that means that this distance r, my hypotenuse r, has to be 13. It's a 5, 12, 13 right triangle. No big deal. All right, so now what I need to do, since I know my r value, right? R is equal to 13 without doing all the work. I now have to go find my angle theta, right? So we know that the positive x-axis is 0. So what angle is going to bring us all the way up to here? So what I like to do, we're going to go to our graphic calculator, and we're going to type in tangent inverse, so arctan on the numworks, and we want y over x. So we're going to do 12 over negative 5. 12 divided by negative 5. And I always hit parentheses too early. All right, so that's going to give us the angle that we need. X. So negative 67 degrees. Well, negative 67 degrees is down here. Shoot, I want this angle up here. So in order to get from negative 67 degrees to this angle that I need up here, we're just simply going to add 180. Okay, add 180. Oh, I guess you can't see this. You couldn't see that. It's so silly of me. All right, so the angle that we're looking for, theta, is 112.6 degrees. So we say the tangent inverse of 12 over negative 5 is 112.6 degrees. I forgot that I was sharing my calculator. You couldn't see all that. Right, so what I was saying is that whenever we plugged in tangent inverse at 12 over negative 5, all right, we got that negative 67 degrees, which would have been down here. But we wanted this angle up here, right? We knew we were in the second quadrant, so we needed something between 90 and 180. So that's 112.6 we got from 180, or that negative 63 plus 180, right? 180 away to get me back to the angle that I needed. Right, so again, tangent inverse is only going to exist between negative 90 and positive 90 degrees. So when we plug it in our calculator, it's only going to give us those possibilities. So if we're in quadrant 2 or 3, we need to be very mindful of how we get to that. All right, so now that I know my radius, how far away I am, and I know my angle, we could say that the coordinate point, negative 5, 12, converts into polar as r comma theta, so 13 comma 112.6 degrees. All right, again, this is rectangular, and this is polar. All right, let's try this other one here. Negative 6, negative 8, negative 6, negative 8. That's going to put us in the fourth quadrant, or excuse me, the third quadrant. Negative 6, negative 8. That negative 6 is somewhere in here. And if we think about the triangle that we're drawing, that means I have a distance of 6 here and a distance of 8 here. I know, yes, it's a negative 6 for x and a negative 8 for y. All right, negative 6, negative 8 is that coordinate point. So that distance there, we could use Pythagorean if you want to, go through the whole thing, but this is just a double of a 3, 4, 5 right triangle. So 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So that means that my r value here is 10. I didn't have to go through the whole Pythagorean theorem to figure it out. But I do need to use my calculator to go find what that angle is going to be, right? So I know that theta is going to be tangent inverse of y over x. My y value here is negative 8. My x value here is negative 6. Yeah, I could just put 8 over 6 in the calculator, of course. So tangent of 8 over 6. All right, that says 53 degrees. 53.1 degrees. So 53.1 degrees. That's not what we wanted, right? 53.1 would have put us somewhere over here in the first quadrant. So in order to get there, we have to add 180. And then we left with theta equals 233.1 degrees. So now we know our radius and we know our theta. So in rectangular form, the coordinate point -6, -8 turns into polar form 10, comma 233.1 degrees from rectangular to polar coordinate. Yes, honey. All right. There you go. Great drawing. So this one coordinate point is 0, 12, 0 in the x, 12 in the y. I really don't need to do a lot of work here. I know that I'm 12 units away from the origin, and the angle to get me there is going to be 90 degrees. So, well, excuse me. So in polar form, I know that my r is 12 and my theta here is 90 degrees. If I were to do that in radians, I'm not going to brag, but it would just be 12 comma pi over 2, right? Here we have root 2 over 2 comma root 2 over 2. So if we went through the whole process, right? So it says r squared is equal to x squared plus y squared. So our r squared is equal to our x value squared plus our y value squared. So square root of 2 squared is 2, 2 squared is 4, plus same thing here. And 2/4 plus 2/4 is 4/4. So our r squared value is 1. Now we can go through and look what tangent is going to give me an x value root 2 over 2 and a y value root 2 over 2? What angle? Tangent of what angle? X and y have to be the same, which means that has to be a 45-degree angle, right? I feel like we should be okay with that. So here for our polar coordinate is 1 comma 45. Yeah, they gave us space down here, but I'm too lazy to go write it twice. So this one's a lot more interesting. 3 root 3 comma -3. So if I were to think about that in terms of an XY ordered pair, right? Here's my X and here's my Y. I go some 3 root 3 distance in X and then a -3 distance in Y. So that puts me in the fourth quadrant, right? All right, so let's do the work to go figure this thing out. We know that r squared is equal to x squared plus y squared. So our r squared value. So 3 root 3, when I square that, that's that. 3 times 3 root 3, that's 3 times 3 times root 3 times root 3. 3 root 3 is 9. Well, the square root of 3 times the square root of 3 is the square root of 9. So that's 9 times 3, or 27. And -3 squared is a positive 9. And so our r squared value is equal to 36. How friendly. So our r value here is 6. And now to go find theta, plug it into our little formula, tangent inverse of y, which is -3, over x, which is 3 root 3. You could figure that out, right? We should be able to figure that out. I know that my values are going to cancel here. So what angle has a sine of 1/2 and a cosine of √3/2? And it's going to be in the fourth quadrant. But a sine 1/2 and a cosine of √3/2. Sine 1/2, and then so that tells me it's going to be like 300 degrees? No, 330? 330. $5. Let's go get it. Yeah, so -60 is probably what's going to end up saying. So we're going to say shift arctan of -3 divided by 3 root 3. And we get -30 degrees. Right? -30 degrees, same thing. That's 330 degrees. So we get, so theta is 330 degrees. So R6 theta is 30. F -√2 comma -√2. We got R squared is equal to -√2 squared plus -√2 squared. So R squared is equal to 2 plus 2. R squared is equal to 4. So R, this is 2. Now, theta, since I'm in quadrant 3, -√2, -√2 is here. I know my that distance, right? It has to be a 45. So it's 1, 2, 3, 4, 5, 45. I can't do that kind of math. So 180 plus 45, 180 plus 20, so 200 plus 20, 225. All right, so our theta is 245 degrees. Yes, you could put that in the calculator. It will kick back with theta equals 45, and then you just add that to 180. Essentially what I did anyway. So that's where we get the coordinate point, 2 comma 225, the polar coordinate point. All right, so let's graph some points, right? Graph the coordinates on the supplied graph. Each point is in the form of r comma theta. Each ring of the concentric circle has a distance from the origin of 1. All right, so this point A, 4 comma pi over 3. So I imagine that I have like shoes, heels, whatever, and I'm standing on the origin. I want to face theta, and then I want to travel a distance of r. All right, so we face theta and travel, and I'm going to use distance loosely because it's really a vector. Right, so we're going to face theta, and then we're going to travel this distance r. All right, so for this problem here, A, we got to face pi over 3. That's 12, 6, 4. Okay, so we're going to face pi over 3. I'm going to face that direction, and then I'm going to travel 4 units away from the origin. So facing pi over 3, we travel 1, 2, 3, 4 units away. And there's our coordinate point for A. For part B, R is 5, theta is -3 pi over 4, so -1, 2, -3 pi over 4 is here. And we have to travel a distance of 5. So 1, 2, 3, 4. Ooh, all the way to the edge of that graph. That's what point B is. All right, so here we got to face 11 pi over 12. Is that you? No, that's not you. Yeah, there you are. All right, so 11 pi over 12. The 11 pi made me think it was you, but that's 11 pi over 6, not 12. 11 pi over 12, and we got to travel a distance of -5. So I'm facing 11 pi over, I'm going to face that direction, but I got to travel a distance of -5, meaning I'm going to go backwards 5 units. So I'm facing 11 pi over 12, and I travel a distance back 1, 2, 3, 4, 5. So take note of what just happened. If my R value is negative, I'm traveling backwards, right? So think about your shoes, right? If you're facing 11 pi over 12, you travel backwards, you'd end up here. All right, let's go to part D. -2, comma, negative pi over 2. So I'm going to go negative pi over 2 here. So I'm going to be facing straight down at negative pi over 2, and then my travel distance is -2 units. Boop, boop, there you are. We're good to go. All right. Hopefully you have no issues plotting those points. There's some more here in the notes to let you do that on your own. Now let's just sketch a graph of R equals 2 cosine theta. So 2 times cosine theta. All right. They gave us a whole bunch of angle measures on here, all the way from 0, every 15 degrees all the way to 360, right? We don't know what cosine of 15 degrees is unless we do a half angle formula, and that's going to be kind of nasty. But we do know 30, 45, and 60, as well as 0, 90, 180, 270, those. So just doing the ones that we know. We got 0, 30, 6, oh, 45, Dave. 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, 300. We're missing 315, 330, and 360. That's tough. All right. So R equals 2 cosine theta. So here's our theta. We got to go figure out what R equals, right? So I'm just going to plug these values in. R equals 2 times cosine of 0. And cosine of 0 is 1, right? So R equals 2 times 1. So we get a 2 back out. And we go to 30 degrees. All right, so R equals 2 times cosine of 30. Cosine of 30 degrees, the x value at the angle of 30 degrees is going to be root 3 over 2. So 2 times root 3 over 2, and the 2's cancel out. We're left with root 3. So we get a root 3 there. That's not going to be really friendly to graph, though, is it? So what is the square root of 3 as an estimate? 1.7. So the square root of 3 is roughly 1.7. What about the square root of 2? We're going to run into him, aren't we? And the square root of 2 is about roughly 1.4. All right. So instead of a root 3 there, I'm going to plug in a 1.7 as we go along and fill this out further. We're going to see a little pattern develop, right? R equals 2 times cosine of 60. And the x value, when our angle is 60 degrees, is 1/2. And 2 times a half is just 1. So we get a 1. And R equals 2 cosine of 90. Cosine of 90 is 0, so 2 times 0 is 0, so we get a 0 there. Oh, biscuit. I skipped my 45, didn't I? Oh, yeah. R equals 2 times the cosine of 45. Oh, that's not really friendly. 2 times root 2 over 2, which equals root 2, and the square root of 2 we said was 1.4. All right, 120. Well, my x value there is a negative 1/2, right? So R equals 2 times the cosine of 120, which is 2 times the negative 1/2, which is negative 1. There's a negative 1 there. cosine of 135 is going to be a negative root 2 over 2. So r equals 2 times the cosine of 135, which is 2 times negative root 2 over 2. So we get a negative root 2 or negative 1.4. I don't want to do this. This is really painful. Can we all agree with that? So whatever we get for our cosine value, can we just multiply it by 2? Wait. So at 150, my x, my x value right there is a negative root 3 over 2. A negative root 3 over 2 times 2 is negative root 3, or negative 1.7. And at 180, it's negative 1, and negative 1 times 2 is negative 2. At 210, we got a negative root 3 over 2 times 2 is negative 1.7. And at 225, we have a negative root 2 over 2 times 2 is negative root 2 or negative 1.4. 240, we get negative 1 half times 2 is going to be negative 1. 270 is 0. 300 would be a positive 1. See that pattern starting to develop there? Now we got to go plot all of these. And we get to see what happens. What happens to this graph? What does it look like? All right, so when we graph in polar, things are a little bit different. Right, we're no longer in XY coordinate points. We're in r comma theta. So depending on the angle depends on my radius. So it's going to look a little bit different. So plotting all these coordinate points. Theta is 0, my r value is 2. So I'm facing 0, and I go in r value is 2. And I go right here. There you are. Facing 30, I go in r value of root 3, which is 1.7. So it's going to be a little less than 2. So we're going to go 1.7, you're here. At 45, we're at 1.4. So we go 1, a little bit less than halfway. There you are. And at 60, we're at negative, or at 1, excuse me. So I face 60, I go a distance of 1. So we're here. All right. When I face 90 degrees, when I face 90, and I got a value of 0, so that's the origin. At 120, I go a distance of negative 1. So I'm facing 120. I'm facing 120. I go a distance of negative 1. All right. At 135, I go a distance of negative root 2 or negative 1.4 here. At 150, I go a negative 1.7. That's a little bit closer to 2 there. And then at 180, I go a distance of negative 2. So facing, I go a distance of negative 2. And I'm here. And really, all of the angles over here are going to have negative r values. All of the angles over here are going to have positive r values, and it repeats themselves. So ultimately, what did we just draw? This is nothing more than a circle. Which I think is pretty cool. Pretty neat. Okay, try one more. All right, so sketch the graph of r equals 2 sine of 2 theta. Oh, no. All right, 2 sine of 2 theta. Okay. Let's get all the ones that we can in there. We have 0, 30, 45, 60, 90, 120, 135, 150, 180, 210. Yeah, we got to figure out what's going to happen with the negatives. 225, 240, do that, 270. Okay, so we've got to plug away, see what we get. So R is equal to 2 times the sine of 2 times 0. The sine of 0 is 0. And 2 times 0 is still nothing more than 0. So we get 0 out of that. Sine of 30. So let's face that we got 30. So R equals 2 times the sine of 2 times 30. 2 times 30 is 60. So we get 2 times the sine of 60. The sine of 60 is 1 root 3 over 2. So we get 2 times root 3 over 2, which is no more than root 3. Which we're going to estimate as 1.7 here. Okay. 2 times the sine of 45. So R equals 2 times the sine of 2 times 45. 2 times 45 is 90. 2 times the sine of 90. And the sine of 90 is 1. So we get 2 there. All right, well, we're going to theta of 60. R equals 2 times the sine of 2 times 60. So 2 times the sine of 120. The sine of 120 is a positive root 3 over 2. Is that right? So we get just a root 3 or 1.7. All right, face 90. R equals 2 times the sine of 2 times 90. So 2 times the sine of 180. The sine of 180, the y value in the face of 180 is 0. And 0 times 2 is still 0, so we get a 0 there. Oh, here we go. We can do hard things. So 120 R equals 2 times the sine of 2 times 120. 2 times 120 is 240. So the 2 times the sine of 240. All right, so 240 is here. All right, 240 is here, close to 270. Our sine value there is a negative root 3 over 2. So 2 times the negative root 3 over 2 is negative root 3. So that gives us a negative 1.7. 135. Here we go. R equals 2 times the sine of 2 times 135. So R equals 2 times the sine of, is that 270? Ah, that's negative 1. So 2 times negative 1 is negative 2. Negative 2 there. Okay, 150. Here we go. All right. So R equals 2 times the sine of 150. Oh, that's 2 times 150, excuse me. So 2 times 150. So 2 times the sine of 300 would be 2 times the negative root 3 over 2 again, right? Which is a negative root 3. Negative root 3. Well, all right. So just let's talk our way through the rest of these, right? 2 times 180 is 360. The sine of 360 is 0, so we end up with a 0 there. 2 times 210 would be, what, 420, which is 60 away. That's a positive root 3 over 2. Multiply that by 2 is a positive root 3 or 1.7. We're starting to see a pattern here. 225 would bump us up to 450. 225 times 450 is 600. 600 times 450 is 650. 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 600 times 450 which would be 30 more, 450. That's I would be at the 90, right? So that's a positive one. Two times one is two. We're starting to see that pattern, right? That would be 1.7. 270 times two would be what, 540, and 540 would put us. Where would 540 be? What is 540? That would put us right at the 180 mark, wouldn't it? 75% confidence, right? 36 plus 18. Yeah, that's right. Yeah, that's zero. Yeah, it's a pattern. I knew it. Ah, I knew it. All right, so now we have to plot all these points, right? Zero, zero, we didn't don't have to worry about him. All right, I'm facing the direction zero and I'm traveling a distance of zero. There he is. So 30, 1.7. So I'm facing 30 and I'm going to go a distance of 1.7. So we're going to be out closer to 2, but not there. At 45, I'm going to face 45 and go a distance of 2. There you are. Face 60 and go a distance of 1.7. So there you are. And I'll face 90 and go a distance of 0. Boom. Okay, that works. Now we go 120, and I'm going to go a distance of negative 1.7. So facing 120, go a distance of negative 1.7 would put me here. I face 135 and go a distance of negative 2. I'm going to face 150 and go a distance of negative 1.7 or negative root 3. And then at 180, I'm back to 0. And then we go to 210, and I go a distance, facing 210, I go a distance of 1.7, so that puts me here. At 225, I go a distance of 2, that's there. At 240, I go a distance of 1.7, you're there. And at 270, I'm back to 0. Now, whenever I calculate these values, right, for 300, 330, 315, they're all going to produce negative y value. I know that because of the doubling nature would put it in the bottom half. Our y values will all be negative. And looking at this pattern, that just tells me that we're going to have points here, here, and here. So to graph this, if I start at 0, 0, and bubble out, I end up creating petals. That was not great, but it is true. That is what the graph of two sine and two theta would look like. And if you want to see it like on a calculator, I don't know why, but we would do it anyway, just so you can see what it looks like on graphic calculators. If I go to grapher, I hit OK. Sure. Uh, how do we go about doing this? I've never done that before. So this is not the time to figure it out. I would imagine it's probably somewhere in settings. Really? Can I graph in Poland? think so. Maybe, I don't know. Let's go find out. X equals, oh no. Oh, we said, oh, I bet this, watch this. Two sine, and if I hit this until I get to theta, oh, we wanted two theta, right? It automatically picked up that it wanted to do it in polar. Brilliant. Very smart. You get to pick it up. So that's so neato burrito. Cool. Calculators are smart.